And then I'm sure you can do whatever you want, but let's take a moment and repeat the Pledge of Allegiance with me. I pledge allegiance to the flag of the United States of America, to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. All right, fantastic. This is really odd. I don't, I don't know. I've never done this either. I'm just grateful that you guys are online. It has been a interesting morning. I I understand there's some pretty major problems with the Canvas right now. So hopefully it will work throughout the day. They tell me if you go straight to the link and a different pathway than normal, you can find your way there. I'll look that up and send it to you later in an announcement or an email. So the first thing I want to do today, and I don't want to spend like a ton of time on it, is an attendance statement. So I put things in writing to try and clarify things. So just if you can read through that with me, I'll go pretty quick. Just for this week, students are expected to be engaged in learning each day. Next week, it's a makeup test or whatever you need. But um, if you're engaged, I will mark you present. I'm going to start this timer so I don't go too far. Um, if you are not engaged, I'll mark you absent. So the definition of engaged, that you need to do these three things that you can see on your screen right there. You need to be present in any of the three Zoom meetings throughout the day, or you need to watch the class recording for the day posted on Canvas on the daily plan page. And I hope by now you know where that's at. Number two, students must fill in the attendance form. And I have that in the chat, but that's part of the class link problem. You may be able to access that. Let me put it in the chat one more time and you can see if it will work. Um, oh, that's great. I can't even paste into the chat right now. So good morning. Um, anyway, typically, if our technology is working, you can read that in bold. The attendance form can be accessed by attending the live Zoom or fifth or sixth hour, or by watching the class video later. The class video, I had it right here. Change. I'll have to email it out because it definitely is not working. Give me about 30 seconds one more time. Well, that's just dandy. Let me copy that. So I'll drop that into the chat. It may work on your end. It does not work on my end from the school. We're having some pretty serious issues with anything related to Google right now. All right. And that looks ugly. Just be patient with me. All right. So if you're at home and watching this video, you would access that through the chat or type it in. Okay, moving on. Let me move that a little bit more. Oh my heavens, Tom. Then number three, students will need to complete the daily assignment on Canvas by the end of the school day. I'll consider that 4:30 if you would complete everything. You should be able to complete everything in like 35 minutes. So if you just log in normal class time, you should be fine. Okay, daily Zoom. I already talked a little bit about this with you on Friday. First hour, that's the hour that I will record and teach the whole time. Fifth and sixth hour, I'll be on to take attendance, but that is all. And I'll just take attendance in the first couple of minutes and say, hey, this is what we did today, and go watch the video. All right, so you can read that. The bottom here, The daily assignment will be a short assignment or quiz that provide practice on the topics covered that day. The daily assignment is not intended to take more than 5 to 10 minutes. At the very bottom, it is intended that the combined time needed to watch the class video and complete the daily assignment will not take any longer than a normal class period. And then many times the daily assignment will be completed as we go through the class video. So that is kind of what we're going to do today. And we'll do that every day this week. So has anyone been able to access this form from your home, or is it not working there either? Just give me a thumbs up or somewhere in the chat, or you can light your mics up and tell me to.
Mine's just trying to load.
Okay, so that's what it's been doing here. Anything connected to the school and Google is just crashing. So don't stress about that. Just do the assignment. Oh, well, there you go. Jack Holdaway, we got one that worked. I'm not sure what's going on. I'm not going to stress about it. Just do your best and do that assignment and submit it sometime today if you can, and we'll just be fine. Okay, so that's that. Content-wise, this is our plan today. So our goal is to be able to determine the number of protons, electrons, and neutrons in an atom using the periodic table. Then, hopefully, you can describe the charge, location, and relative and actual mass and role in the atom of the proton, neutron, and electron. And then finally, describe what an isotope is and be able to identify an isotope when given a list of atoms and a periodic table. So what I need you to do, we'll give you a 30 seconds or more. Take out your Atom lab book and go to page 9. We'll be on page 9 and 11 today. You'll also need your periodic table, and you'll probably want a calculator. All right, we're not doing anything besides just subtracting or addition. But if you do that in your head, sometimes you mess up. That's interesting that it took you to Google Maps. I have no idea. All right, so go ahead and grab page 9 and 11 is where we'll be. Let me double check those numbers. Yeah, number 9, properties of subatomic particles. All right, so I'll go ahead and advance the slide to there. Well, just quick. This, they say when you teach, if you show kids what success looks like, they're more likely to feel success in the end. So by the end of today, you should be able to fill out a table where you can tell me the protons, neutrons, and electrons given the element symbol and a periodic table. Okay, and that's what you'll need the calculator for. It's no big deal. Number 2, which of the following would represent an isotope as written? So you would look right there, and I'll teach you how we would do this. It's pretty simple. And then number 3, where are the protons, neutrons, and electrons located? Hold on real quick. That doesn't work. All right, well, I thought I had a good idea and it didn't work, but that's how the morning's gone. Okay, so if you are on page number 9, the first thing we have is actually a ton of writing. So the top half of page 9, it gives you the column for electrons, protons, and neutrons. If you will fill that out, I will give you about 4 minutes to write as fast as you can. I'm going to pause this video while we do that, or pause the recording. Okay, so what we have here is literally the properties of the electrons, protons, and neutrons. And it's something that we need to know pretty well. On your exam, you'll have a matching section. You're probably used to those because tons of my questions are written that way. And it'll just list a property, and then you are supposed to match it to one of the electron, protons, or neutrons. So make sure you're comfortable with each one of these. It's kind of just memorization, and I'll probably do some sort of engagement activity if I can. Usually we do a Quizlet live. I'm sure those work too, remotely. We'll see. So anyway, electrons, they are negatively charged. We should be comfortable with that because we had a long time ago, J.J. Thomson discovered that there was these things that were negatively charged in the atom, that he could change their direction based on being an electric field. All right, then they live, their location is clouds outside the nucleus. So we should be comfortable with that. We had our protons and neutrons here, and then we had our electrons that were just zipping around here in these clouds. They're really small, 9 times 10 to the 28 grams. So they're so small, we say their relative mass is 0 compared. Number 5, the electron number is equal to the number of protons. And we'll talk about that in a few minutes. The electron is responsible for the chemical properties of the atom. The chemical properties are what we usually care about because we are in a chemistry class. All right, so those are the electrons. Make sure you're comfortable with those. Protons are positive. They are found in the nucleus. They have an actual mass of, holy group me's, 1.7 times 10 to the negative 24. So they're quite a bit larger than the electron. So we say they have a mass of 1. They are a definite number of them in the atom. The protons define the atom, and they're responsible for the physical properties of the atom. Then neutrons, they're the boring ones. They have no charge. They are also found in the nucleus and have essentially the same mass as a proton. So both of them, we say their relative mass is 1. The neutrons, the number of those can vary in an atom. And we'll call that an isotope. We'll talk about that today as well. And then the neutrons are responsible for stabilizing the nucleus. They're what keep everything together. All right, so this table, you will see it. I can't log into Canvas right now at the school, but if you were to go to Canvas, you would notice that there's a quiz that is practicing the properties of subatomic particles. You can take that quiz over and over and see how that format is. So anyway, that table almost word for word will be on your exam. So these are the properties of these particles that make up the atom. All right, next up. Oh, hey, there's everybody. Just underneath that, we have the atomic number, and it has these 3 parts. The atomic number is defined as the number of protons in the nucleus. So if I have the hydrogen atom, it has 1 proton and 1 electron, okay? We would say that the atomic number, since there's 1 proton, the atomic number is 1. All right. Each element has a characteristic number of protons. That's the thing that identifies the atom. So if I were to change this to a 2, I keep looking at the wrong screen, and now there were 2 protons, I would no longer call this hydrogen. I would now call it helium, because helium, oh, nothing is working right today. Helium is element number 2 because it has 2 protons. All right, the elements can be arranged in order of increasing atomic number, and that's what we call the periodic table. All right, hopefully you're okay with that. Now, if we look at the periodic table you have, you will notice that we have a large number, which we've been using for a long time, and a small number. We've been using the large number to represent the mass of the atom. We are used to that. We are now, as far as atomic number, we're always talking about the smaller of the 2 values. So I would say that bromine, it's element number 35. It has 35 protons. Xenon, 54. It has 54 protons. That's its identity. So the atomic number is really important. it tells us what the atom is, and it tells us the number of protons. All right, how are we doing? If you have a question, just buzz right in and ask. I can hear you. The chat, I shrunk it down. Hold on. If you put it in the chat, it'll be a lot slower. Yeah, I don't even have it open. So just talk if you have a question. Okay, go ahead and fill these blanks in. And maybe I'll reopen the chat while you do that. Okay. All right. Wow, time is flying. I am dedicated to end in about 11 minutes of the video. We can talk homework a little bit after that, or the daily assignment. All right, so the atomic mass number. Now, spoiler alert, we've been using this the whole time. The mass number, whoops, is the bigger number. We have been calling it the gram formula mass, or grams per mole. And that's just the bigger number. So helium, we'd say it has a mass of 4 and an atomic number of 2. Okay, this number is equal to the sum of protons and neutrons. So we take the protons, we add the neutrons, and that will give me the atomic number. Now, in each one of these squares, I have, sorry, not the atomic number, the atomic mass. In each one of these squares, I have 2 numbers, but I need 3. The number we're missing is the number of neutrons. So we have to do a little bit of math to figure that out. So the atomic number, that's the small one, and that's given to us. It's equal to the number of protons. All right? The number of protons, it turns out, is equal to the number of electrons. All right, this is also the small number. So the small number in the box will tell me both the protons and the electrons. But then I have to do the math, and that is the number of neutrons. The number of neutrons is equal to the atomic mass number minus the number of protons. So the atomic mass number is the big number, and the protons is the small. So another way to say this is that the number of neutrons is equal to the big minus small number. And we're going to need to do that quite often. Let me bring that higher in case you can't see that. We're going to need to do that. I'm going to give you a symbol to look for on the periodic table, then ask you for protons, electrons, and neutrons. So one more reminder, just real quick. Protons is equal to the small number in the box. All right, electrons equal to the small number in the box. Neutrons, big number minus small number. So let's go ahead and practice. Number of protons and neutrons in the following. So I have nitrogen. That is right, I keep looking at the wrong screen. Nitrogen is right here. So I have a big number and I have a small number. All right, tell someone in your house, the small number tells you what, and then tell them what the big number tells you as well. I'm sure everyone's asleep, so just at least pretend. All right, so in order to know the protons, oh, I forgot electrons here. In order to know these things, I look at nitrogen. I know that the protons and the electrons are equal to the small number. Small. Small. So I look, and that's a 7 and a 7. And then the neutron is equal to the big minus. I like it. Thank you, Megan. All right. It's the big minus the small. So I have 14 minus 7, and that equals 7. So nitrogen is a pretty simple one because they're all three the same value. That does not happen every single time. So we can look right there at Se. So selenium is right here. Oh, that circle didn't work out very well, but you can see it. The small number is 34. So I have 34 protons. I have 34 electrons. I just got an email that class links is not working. That was about 2.5 hours late, whatever. Okay, so Se, I have 34 and 34. And then to find neutrons, I take the large number, 79 minus 34. And I can't dare do that in my head. I'll look stupid. 79 minus 34 equals 45. So I put a 45 right there. Okay, well, you try fluorine, neon, and bromine. They're all on here. Sorry, boron. They're all on here. Take about a minute and give that a shot. All right, so let's see, first day in already sort of screwed up and I paused the recording and never restarted it. So we'll just go from here. So I believe I had paused and asked you guys to work from here down. So just to double check our understanding, we have fluorine, which has a 19 and a 9. The protons is always equal to the smaller number, so that's a 9. The electrons is always equal to the smaller number, which is a 9. And then the neutrons are always equal to the big number, which was 19, minus the small number, which is a 9, and that makes a 10. So fluorine 9, 10, 9. Neon, one more. This one's pretty easy. The small number is a 10. So that's the number of protons and electrons. And the bigger number, which is 20, minus the smaller number, that makes 10. Okay, so hopefully you were successful with that. Now, your assignment that I need you to do on Canvas, it's on Canvas. It's at the bottom of the atom module, and it's called Proton, Neutron, and Electron Practice Problems. If you would go there, you'll see this same sheet. It says it says write these down, then take a picture and submit it. So what I need you to do, we'll do a few together, is do that and then submit it. So this one's a little bit trickier because it asks for protons, neutrons, and electrons, mass, atomic number, and it gives you just a piece of the puzzle. So a few things first. Atomic number, protons, and electrons are always the same value. They're always the same. So right here, this one is an 11. That would mean this one's an 11, and it would mean this one is an 11. Okay? Then a comment about the atomic mass. Some of these will be called isotopes. And we were supposed to cover that today, but I definitely ran out of time. So isotopes means that they have a different number of neutrons, which means their masses are not the same as the ones listed on the periodic table. So don't look for masses on the periodic table, just do the math. All right, so the atomic mass is equal to protons plus neutrons. That will tell me the atomic mass. Okay, then neutrons are the tricky ones right here. So neutrons, hopefully you remember from the previous slide, your neutrons are equal to your mass minus atomic number. All right, so it's this column minus this column. Okay, so let's go ahead and attack this top row. We have boron, which we just barely did. Boron is right over here. It has an 11 and a 5. So let's go ahead. We know that the big number is 11. That's the mass. We know the atomic number is a 5. I know that that must be equal to the protons. That must be equal to the electrons, because these three columns are always the same. Okay, coming down to the next row. It doesn't tell me what the atom is, but this number always determines what the atom is. So I just need to look at the periodic table, and I need to find the one, whoops, that has an 11 as the smaller value, and that it was, spoiler alert, it was already there. That is Na. It's 23 and 11. So I know 11 is Na. Now, here's that warning about isotopes. On the periodic table, it says the mass is 23. This one says the mass is 24. That's fine. It is an isotope. Okay, to find the neutrons, I need to take the mass, 24, and I subtract the atomic number. That's 11. So that equals 13. That's the number that goes there. Okay. Coming down here, protons. Remember, protons are nice. That tells me this column is 31. That tells me this column is 31, because these three, number, protons, and electrons, are always the same. Once I have this, that will tell me what element I'm dealing with. So I look for element 31, that the small number is 31, and that's Ga, which is gallium. Okay, then the last thing is atomic mass. The mass are protons plus neutrons, so that would be 68. That doesn't look like a 68, but it is. Okay, let's do one more. I'm going to erase all this stuff because it's just getting crowded. The electrons are 39. Okay, remember, same. So electrons are 39, protons are 39, atomic number is 39. So I can go to my periodic table and I find element number 39 is yttrium, which is Y. Neutrons, final thing to locate neutrons is the big number minus the small number. 89 minus 39 is 40. All right, I'm suck at math. That is 50. All right, so I would put a 50 right here. Okay, so please do the rest of these on your own piece of paper, take a picture and upload it in Canvas, and you should be good to go. And that's our assignment today. If you were unable to at the start, please try and go here. And once you get there, and I know that's long to type, it was in the chat if you were here live, go here and mark your attendance for the day. All right, I hope that that helps. You guys are awesome. I'm sorry things didn't go how they were supposed to go today. Hopefully better luck tomorrow.